course is called Exploring Engineering. It was developed as the intent as a survey course. Having done a robotics club for a couple of years and talking to the students there, I recognized that they were interested and there was a need. And in a lot of conversations I'd had with students and engineers and peers, the students really didn't know what engineering was. And if I talked about mechanical engineering or I talked about electrical engineering, they really didn't understand the difference. So it was meant as a survey of what the differences were between them. And so I had picked 4 or 5 that I would start with that were very basic. First was getting them to understand the engineering development life cycle. Then it was mechanical. Then we went into a little bit of software engineering, because I really worked to create transitions into each so they could see how the different disciplines worked together, that it was more of a meshing and not a smokestack concept. So I ended up with, right now, we have, first is the engineering design process, that's Unit 1, Unit 2 is mechanical, Unit 3 is software, Unit 4 is electrical, and Unit 5 is civil. And I have a culminating project, which is getting them to look at different sources of energy through to how electricity gets into the home. And it's very eye-opening to them along the way. And so now we've been running, this is our 4th year running it, and we are still 3 sections, 25 to 29 students, and we're usually overbooked. It's still 90% boys. I'm working on the girl bit. I'm working on it. I have a little bit more this year. I have 8 girls this year out of a class of 20, well, 2 classes, so between 50 students, 8 of them are girls. But it's a learning curve on that, on how I'm going to improve that. Unfortunately, in our school, there isn't a way to give girls first priority, so it's still kind of a gamble on how that happens. We're still trying to work that more. But and a lot of it is you don't sign up for this course unless you have some interest in engineering, so it's working how to cultivate that interest as they get ready for it. It's a junior-senior class, so we're still working on building that interest in a lower level and finding ways to do that. So in developing the course, I took a big leap, because while I have been a software engineer in my past life, I did not go to engineering school. But I felt comfortable that I had enough knowledge to be able to show the students and open their eyes. I fortunately found some people to help me, and I had a few volunteers from the community that were really eager to help. I also had a lot of help from Boston University, which I have an affiliation with, and know the Dean of Engineering really well, and he was part of what got me interested. But we developed it based on current knowledge and came up with projects that were really the foundation for what they needed to know. I stole everywhere. Every idea that came and said, oh, that's cool. I used it. So to get them to understand the engineering development process, I stole the concept from the IDEO labs. And they would walk in, and I give them a notebook and say, here's your project. Create a better shopping cart. And that was it. I'd walk away. As the course has developed over the years, we've learned to phrase it better, to bound it better. So now it's also, it has to be to scale, which was a whole new concept for them, completely new concept. And always the boundary was it had to fit in the box. So we had something to cart it back and forth, because I don't have a real lab. There isn't good storage space. So God bless W.V. Mason paper boxes. Everything had to fit in the box. And then, I forget where I'd seen it, or if it was just, I got excited about it. It's one of those, wake up in the 2 in the morning and go, oh, I could do that. I had them build a Rube Goldberg machine, which really had them understanding things working together. And the first year we did it, that's what they did. And then this year, I recognized, and from one of the ITEA and ASEE conferences I've been to, was that aspect of throwing in probability and having them looking at it as a system. And this year that was a big thing, is what is your system probability versus individual probabilities. Getting them to understand that whole concept of system engineering. And it was fascinating to watch them. I mean, the class was completely engaged. Number one resource is cardboard. It's the most plentiful, easily to use, and we all laugh about it and go, cardboard? But you can do so much with it. So almost all of our projects we build with cardboard. And the students are learning that it may be one material now, and yeah, maybe they want to use plastic or things like that, but they're understanding that you've got to have what you've got and how to work with it. For people, I've been really, really fortunate. I did a big article in our local paper, and I had a couple people contact me that they'd be interested in helping out. I have a company that's been great, that letting the kids come in and take a tour and understand, and they get to see what manufacturing engineering is, high-tech, fully automated manufacturing lines right here in town. And I have people that come in and speak all the time, and you would be so surprised on how willing people are to come in and talk. We have a resource officer. So he came and did a presentation about a taser, which is the ultimate proof of electrical engineering. And this year when he did it, he had even gone off and done more research compared to what he did last time, and he came in with numbers. And you know that it's a charge of 50,000 volts, and the current is 0.0036. So I'm taking these numbers and he's showing them how to do it, and they're all excited. We all learned very cool things about the taser. But we've been working really diligently with Ohm's law. Volts, resistance, current. There's a relationship. And when you use 50,000 and a current of 0.0036, that implies huge resistance. And I'm looking at this and going, that doesn't make sense. So I turned to one of my retired electrical engineers that had been working with us and said to him, this doesn't make sense. He went off and did some research, and he came back with the whole explanation of how the numbers fit in and what it is, and talked to them about peaks and voltage peaks versus current peaks and things, and expanded the lesson 200%. That we even went back to the officer and explained it to him, and we actually made an assignment out of it. The kids had to write an essay that explained it back to Officer Dad how those numbers will work. One of our most successful forays into using resources is contacting our DPW, and they brought a backhoe, which was a chance for the students to really see what an actuator is, a hydraulic actuator, and actually see it big, hands, not hidden, and understand how the backhoe works. And again, this was a case where the first year we did it, they drove it up, they kind of showed it, we did a little bit. The second year they did it, the engineers, the backhoe driver, the DPW employee, went and did research and came back and told them when the first one was, which was back in the, I have to remember when that was, but way back with Babylonians, the first backhoe. I mean, the hydraulics was used then. They knew how to do it then. It wasn't the first backhoe, it was the first hydraulics. But he had done research. He was just as enthralled with it. And the kids' eyes popped. Very simple. It got the town involved. It looked really good for the town. We brought a backhoe to the back of the school. Didn't have to do a field trip, thank God. And yet the kids got so much out of it, understanding what a hydraulic system really and truly is. So, you know, the town resources are available to you, and they want to share. People, just like us as teachers, we love what we do. They love what they do, and they love sharing it. I mean, they were so excited to come back the next year because they saw how interested the kids were. And as I said, they went off and did their own research and came back and expanded the lesson more. Part of Parents' Night is always the first question is, are you an engineer? Would you like to come in and talk to us? And that's worked out very well as well. And it's just, you have to use every resource you have. If you're excited about it, and I find that, as soon as I start to talk to someone, and they see my excitement, engineers get as excited. And they're just eager and willing to come in and talk. And the kids want that reality. And one of my favorite resources. National Geographic had this show called World's Toughest Fixes. And I have a video collection from it. So, $30, I think. And the videos in it, they come in and they take things apart and fix something. And the students are amazed. We got to watch them moving this 90-ton engine off a barge. And, oh, wait a minute. They had to wheel it over, and then just those basic tools of how to get it off a barge that is rising as it gets lifted off, coming onto a flat platform, and how you're using your simple tools to keep everything balanced and organized, basic mechanics. And then they're lifting it up to get it up to the height of where it has to go in the ship. And they've got a problem with their jacks and what they're doing to get the jacks to do it, and this little process of literally jack up, 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 put another brick in, jack up, 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 put another brick in. And then they were using the hoist to go back and forth, and there was a problem, and how do we fix it? And my students were actually yelling at the screen, no, 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 you gotta do this on the right, no, you gotta do this on the left. And they're seeing the problems being resolved. And they're really basic videos, you would think, but it's real engineering problems, and it shows them things they don't get to see otherwise. We did eventually get a book, because at the time I started the class, there weren't any good classroom books. We did get a book that has a good basis for everything that we do, that the kids read as we go along, and it just provides them with a little bit more well-rounded in what we're doing. Goodhart and Wilcox called Engineering Fundamentals. We don't use the whole thing because it covers more disciplines than I currently have right now, but it's a good grounding, gives them the basics. It's not that you have to have a lot of physical resources. As I said, the majority of the stuff that we do is cardboard. Cardboard, hot guns. Hot guns work really well. Hot glue guns work really well. And glue. And scissors. I mean, we've worked mostly with them. As we've expanded, I write out a few grants. I was able to do a grant to get some little Finch robots that we use for our software engineering piece. They're not the most sophisticated thing, but boy, what the kids learn from it. Finding out that, yeah, it only does what you really and truly tell it to do, not what you think it should know to do. So that's probably the biggest monetary grant I've gotten. But a lot of local organizations in your town have grants you get 100, 200, 500. And it seems like a small amount, but it's enough to do something with. I've been getting feedback from students, especially those who've gone on to engineering, and they're always excited when they come back and say, Mrs. Reidy, they had us do a Rube Goldberg machine. It was so cool. I'm so far ahead of the rest of my peers. And it wasn't that because they had done one, they know how to do it, so they were smarter and better. But they understood the process. They worked better in a team. They understood how all the pieces had to work together, and therefore it wasn't that they didn't have good expectations. They were a little bit more realistic. They understood the pieces that they had to stretch and try a little bit harder, and what was going to be harder or easier, and the tight teamwork. They've come back and said how some of them have actually gone into software engineering, having tried the Finch and seeing that, or robotics. But the predominant one that comes back is how far ahead they are in their colleagues, in their ability to truly work in a team and understand the development process and know how to look at a problem and be able to have a better sense of what is it I'm really working with. And they have come back and said they just feel so much more prepared. Well, the biggest feedback I get is from the engineers that I'm working with, the retired engineers, and even current engineers, on how real this course is for the students. They truly feel that what we're giving them are skills and knowledge that they really need, making them think about the fact that a mechanical engineer and a software engineer have to work hand in hand if you're doing robotics. One of my students came back this year and said, wow, programming, when it's to make something move, is so different. That our students haven't had that opportunity. That they've never really seen that it's not just making a little app on the phone. That it's got to be really precise. You have to test it. The concept of testing, of how to make a test that's a unit test versus a system test. The idea of everybody working on a project together and working together to make a system. They also come back and say how much better they are at their research, because we make them look at very specific things, and the knowledge they're learning from that it's not just look it up on Wikipedia or find the answer in a book. I think too that they commented that this knowledge they've walked away with, that there isn't just one right answer, has helped them when they get to college in engineering, and the expectation at a college level that you already understand that. I think the biggest piece of advice I would give if you want to develop an engineering program is to realize you don't have to be an expert in everything. I think we as teachers have that belief that we need to be an expert in order to teach our students the material. That I need to know mathematics inside and out to be able to teach how to solve an equation. And when we start to look at engineering and developing our engineers of the future, we have to realize that we're not teaching fluid mechanics. The engineering skill set is at a college level. There's too much that they need for it. What we're trying to do is show them that while they might think science is cool, or physics is cool, or math is cool, that there's a way to pull it all together. I had a student who thought architecture was what she wanted to do. And she was just going to be a drawer, be able to design. But she was really good at science and really good at math. And when talking to her, I said, you can be an architectural engineer. And it was a light bulb. And that was what her college essay was all about, was that light bulb turning on. And she went and researched it and realized that's really what she wanted to do, because she wants to be able to take it from a design to see it built and work. And she's going to go off into architectural engineering now and really make it work. And what our job is, my belief, and this is, it's me, I think my job at the high school level is to open my students' eyes to say, these are all these disciplines, because you're going to get asked, are you going to be a mechanical engineer or a civil engineer or an electrical engineer? That they're not isolated, but they're skill sets that you build upon. And in order to be able to get those skill sets, you need to know how to look at a problem. You need to know how to work in a team, because our environment now, our world today, 99.9% sure you're going to be on a team. And you need to be able to work with the team. They don't need to be your best buddies. They don't need to be your best friends. You need to learn how to work as a team and work together, because the second project is going to be a different team, most likely. Teaching our students how to look, how to find, how to learn. Teaching them that there isn't always going to be a right answer. There's multiple ways of doing things, and the right answer that they think is today's, that next week is going to be different. And in a year, can be completely different. The other thing that we need to bring to it is our enthusiasm. Because when the students see us get excited about something and go, oh, I want to learn about that. How do you think we would do that? Let them go off and research. Let them teach you. Because that in of itself is a learning. That they need to learn how to present their ideas, how to communicate. Because to be a good team member, you need to be able to communicate with your team and share with them. So don't set yourself up. Don't think that you need to be the expert in all things, because all that's going to do is stall you and make you uncomfortable. You're going to be the expert in how to learn, and teaching them how to learn in an engineering view, how to understand that engineering design process, how to use it to their benefit, how to realize that there's multiple ways of doing things. How do you determine what is best for you? How do you test something? How do you look at its probability? How do you plan your projects to actually get done on the day that's due? Because the customer's not going to pay for it if it doesn't get done on the day it's due. And bring in resources. Show that excitement, show that enthusiasm, tap your community. There's a lot of engineers out there that just love to talk about what they do. That would be my biggest suggestion. Don't try to do everything at once. Start off small. I've done this one survey class, And I'm hoping now, I've got a second class this semester that we're doing, I call it big projects, where the students have a project they want to do, and I'm pairing them with a mentor to help them understand that team process and write a project plan that they can actually do. That's a big part of engineering, is understanding what you can do in a reasonable time and what to do. And you can develop it from there as you go. I do think it's important for them to understand the basics, because there's almost nothing you're going to do in engineering that doesn't involve mechanical or electrical, and in today's world, software. You got to have, the computer talks to almost everything.